Welcome back to another video in the ICD1 video series, and in this video we will be looking at where a firewall fits into our network. So before we go on with this video, I just want to recap on what we covered in the previous video. So in the previous video, we looked at how we can actually build local area networks and wide area networks. Local area networks are built using switches. Switches allow devices to connect together, devices that live in the same local area, and allows those devices to communicate. So share resources, send each other files, and just share information. And when we want to get off our network and access another network, whether that be the internet, maybe we want to go and browse on Facebook or Google, we would use a router. So a router is the device which allows us to escape from our network and access somebody else's network. That could be a network on the internet, that could be another enterprise network. Now the problem with this design at the moment is that yes, we have reachability to the outside world, but we don't have any security at all. What's to stop some rogue device on the internet from hacking into our network and essentially destroying everything? So messing everything up, putting viruses, trojans and worms. There's nothing stopping it. It can access our network freely. There's nothing stopping it. We're connected to the internet, which means that he's able to reach us and he's able to essentially just destroy everything. Now this is where the firewall comes into play. The firewall is a device which sits in between our local area network and our wide area network. So it sits at the edge of our local area network before we connect to our router, which connects us to our wide area network. And what the firewall does, it acts as a brick wall, blocking anything that shouldn't be allowed in, and only allowing things that should be allowed in. So in this video, we'll talk about what a firewall is, and we'll go into more depth. Okay, so the main function of a firewall is that it acts as a barrier between an untrusted network and a trusted network. So our local area network is seen as a trusted network. We can trust the devices that connect to our network since we are the ones that put those devices there. So we can trust that none of these devices want to do anything bad to our network, don't want to mess anything up. But can we truly trust the devices on the internet? The internet allows networks from across the world to connect together. The internet is a wide area network. And because it allows devices from across the world to connect together, we don't actually know, there's no way for us to authenticate those devices out in the internet. How do we know that those devices are trustworthy devices or secure devices? What's to stop a hacker from breaching our network and messing up all the devices in a network? At the moment, there's nothing. This is why we have to use a firewall. So what a firewall actually does, like I said before, acts as a barrier between a trusted and an untrusted network. And it's placed in the forwarding path. So what the firewall will actually do, the firewall will inspect all packets that come through it. So whenever our devices want to communicate with somebody on the internet, our firewall will actually inspect that traffic, make sure that we aren't accessing maybe any websites which are known to have viruses or worms, or we're not accessing something that we shouldn't. And the firewall blocks all connections, all data coming back, and only allows data to come back that was requested from somebody inside of our network. So the way it works, this PC over here sets up a connection to this server, and now only data from this server is allowed back in because that data was requested by a device within our network. Firewalls perform a stateful filtering. So there's two types of filtering, stateful and stateless. With stateless filtering, after a decision has been made to either filter or not filter that traffic, that choice is forgotten. With stateful filtering, the firewall actually keeps track of all decisions it makes and of all connections. So in our example, let's say that we have a switch and we have a PC over here, and this PC initiates a connection to this server over here. Once the firewall has said, okay, that connection to that server is safe, it doesn't forget about the choices made. It knows that it's allowed that connection. It then keeps track of that connection for the duration that connection is up. So for the duration that this guy is visiting this website, The server will keep track, the firewall, sorry, will keep track of all the data that is flowing between this PC and this server. So what it'll do, it will look at all the traffic that it's receiving, and it will only allow traffic back into the network which is sent from the server. Now that means that if some other server pretends to emulate this server over here and tries to send traffic, the firewall is going to block that traffic, because that traffic hasn't been requested by anybody inside of our network. Firewalls also perform packet inspection, in that they can have an in-depth look at the information in our packets. This way, we're able to actually identify whether the server the actual server or that we're accessing, whether that data that's coming back into our network actually contains a virus or some sort of worm or Trojan. With firewalls, we can configure security zones. So with security zones, we can configure security zones and give those security zones different rules. So as an example, let's go back to the example with our network. This is the firewall over here. Make it a bit bigger. We have a router and we have a connection to the internet. This is known as a WAN. This is our LAN. What we can actually do, we can configure our local area network as a high-level security zone, which means it's highly trusted. We can configure our WAN, our wide area network, our connection to the internet, or our connection to the internet as a low security level zone. Which means that we can't really trust the devices on the internet. There's no way for us to really approve or identify what kind of security levels are in place. So by identifying the different zones, we can then create rules which define how these zones interact with each other. So we can say that traffic going from a high security zone to a low security zone is allowed, but traffic going from a low security zone to a high security zone should be blocked, unless that traffic has been requested by somebody already in the high security zone. This means that we're still able to access the internet, but we can stop rogue and malicious devices from trying to get into our network. Now, for devices that have to be internet accessible, we can create a third zone called a DMZ, a demilitarized zone. With the DMZ, a DMZ zone exists outside of our internal network, outside of our high security zone, which allows devices from the internet to access our internet accessible servers, but without having to go through our internal network, keeping our internal network safe. So we can do something like this. We can say that traffic from a high security zone to our DMZ is allowed, traffic from our high security zone to our low security zone is allowed, and traffic from our low security zone to our DMZ is allowed, but traffic from our low security zone to our network is blocked, essentially allowing us to have internet accessible servers without devices from the internet have to go and enter our network to reach those servers. So this was a short video on what a firewall does, and really in the ICND1 course they don't really touch on firewalls in depth, that they just want you to know what they do, how they do it, and why we would use them. So we've seen that we would use them because we need to have security in our network. Routers and switches allow us to connect to our network, allow us to connect to other networks, but there's no security in place to stop somebody, a malicious person, from breaking into our network and essentially breaking everything. With a firewall, we can limit the kind of traffic that can get in and the kind of traffic that can leave, and we can make sure that we're only visiting authentic websites, authentic servers, not trying to communicate with unauthentic devices, with devices that can't be trusted. I hope this has been informative for you, and I would like to thank you for viewing.